And I will start by introducing Mr. Madi. I'm pleased to introduce Mr. Marwan Madi, a principal partner at CDM Smith in Fairfax, Virginia. Mr. Madi's work focuses on the planning, design, testing, and deployment of emerging and smart technologies to promote urban mobility, multimodal accessibility, and economic development. Mr. Madi's work also includes developing relationships with private industry and the public sector to facilitate the deployment of automated and connected vehicle technologies. Mr. Madi's ongoing work included the deployment of an advanced freight information system and smart parking for the Los Angeles metropolitan region, the testing of a freight signal priority system, and the design and deployment of truck platooning technologies for the city of Columbus, Ohio, and the establishment of a smart cities program for the city of North Charleston in South Carolina. Prior to joining CDM Smith, Mr. Madi led Booz Allen Hamilton's Federal National Surface Transportation Safety, Freight, and Technology Transfer Practices. Mr. Madi holds a Master's of Science degree in Civil Engineering from the University of Texas in Austin and a Bachelor of Engineering degree from the American University of Beirut. Mr. Madi's presentation will shed light on specific smart city deployments in the USA. Marwan, the floor is yours.
All right, well, thank you. Well, before I start, I apologize for my voice. Okay, I apologize for my voice. I'm dealing with allergies. It's that time of year, and apparently when you get older, it gets more pronounced. So today's presentation is going to be focusing on the American experience of smart cities, and we're talking about smart in the city here. So, before I get into my presentation, we're covering a lot of different topics. I want to spend a minute or two talking, if I can actually talk, about the agenda that I'm going to be covering today. So first and foremost, I'll be tackling the issue of what it means for us in the United States when we say smart cities, how we define it. I'll talk about the urban challenges that are facing cities and regions in the United States and the role of smart cities, as in why smart cities are so important and prevalent today in fixing those urban challenges. And the interesting thing about this part of the presentation is a lot of you in the room are going to see similarities with what's going on in Lebanon right now and the value of smart cities addressing mobility and sustainability in general. I'll go through the participating cities in smart cities in the US. I'll talk about a few case studies that we're involved in at CDM Smith. And for those case studies, I'm looking at three types of geographies. And these were picked intentionally. Large cities, so I'm thinking of a city that's over 1 million people, similar to Beirut, if you will. Midsize cities, these are the cities that are ranging in size between 150,000 people to 1 million. So a lot of cities in Lebanon could be fit under that. And then small size cities, the examples of Marysville, Ohio, which is a city of 30,000 people. And we have a lot of those small cities in Lebanon. After the discussion of the case studies, I'm going to tackle at a high level what are the drivers that have attracted people to look at smart cities, but also what are the challenges that they've been facing. I'll also talk a little bit about the funding mechanism and business case for smart cities, because I know the earlier panelists talked about smart cities and the value of smart cities. But at the end of the day, it's how much money you have that's going to get you wherever you need to go. And you need to figure out how can you implement smart cities and what kind of funding to use and how do you want to manage it, because it's very advanced in technology and it might require more than just the public sector to work on the project. And I'll tie that on the implementation level to Lebanon, because I know a lot of people in the room are interested in what's in it for us in Lebanon and how can we apply it for us. So with that said, I'm trying to get used to this computer. So smart cities. Smart cities mean different things to different people, and that's the beauty of it, right? You can be someone interested in sustainability. You could be someone interested in resilience. You could be someone interested in addressing mobility problems. I know, Zena, you asked that question earlier. You could be someone interested in making governance more reliable, more transparent. You could be interested in looking at your water and energy system, which are failing perhaps in some cases or wasted. And you want to basically address all these different types of issues, that operational issues that you're dealing with through smarter technologies. And that's basically what smart cities mean for us in the United States. How can I use information? How can I use communication? Put it together, link it to the infrastructure that I have. And the idea is not to get data for the purpose of data, because if you have a volume of information, it means nothing to anyone if you can't translate that to something that's relevant to people. So how do I turn urban and suburban, and really when we talk about smart cities, I have to give a side note, it's not just about the city, it's about the region that covers the city. It's the metropolitan area. So it goes beyond just that limit of, let's say, Washington, D.C., where I live, or New York City. It's Northern Virginia, it's Southern Maryland, or in the case of Beirut, it's the Beirut greater region. So how do we use smart technologies to become more informed, to connect the dots, to make our system more integrated, to decide where our priorities are, what our goals are, how to measure our goals, how to track our systems, make them more efficient, more sustainable, and more productive at lower cost, while taking into account issues related to climate change, density, accidents, safety, security, etc. So what makes smart cities so attractive today? Well, the urban challenges are basically what's driving the entire conversation. I know a lot of you in the room have heard time and again, transportation systems are inefficient. Well, yeah, they've been inefficient for a long time, but we live in an era right now where we have so much reliance on the internet, where we have so many countries around the world that have gained a lot of power in terms of, financial power, that they're coming up on the map and they're demanding their fair share, rightfully so, of dealing with business online, purchasing online. All of those things are going to create different types of congestion, because you're no longer relying on your typical truck that's, collecting goods from country A, moving it to country B, and dropping it at one distribution center, and then having that distributed to the region. Now you have different types of shipments. People are demanding it at different times, so you're moving all around the clock. Population is growing. Population is aging. There's a lot of problems that the current system cannot address. In the United States, for example, congestion is valued at $305 billion annually, out of which 10% of that is just generated by New York City. That's a huge number when you talk about congestion. And on top of that, we can talk all we want about building capacity. We can say, oh, I'll build another road, I'll build another system. Well, there's no space for another road. There's no space for another system. On top of that, you don't have the money. It costs a lot of money. It requires a lot of environmental analysis, benefit cost analysis, and what have you, to use the typical transportation engineering terms, to be able to push for these types of capacity projects. So this is where using technology to address operational issues, to fix those problems, come in. I'm not going to spend a lot of time on the slides, but obviously other issues that come to bear as well. Accessibility for the disabled. 1 billion people by 2050 are going to be disabled. That is not including the people that by 2050 who are going to be in their 80s and 90s. We're living longer. We haven't planned for a large society of 90-year-olds. Yes, they can move, but can they drive? Do they have the family or friend support system to move them? You need to be able to have a system ready to help them move around. The same applies for people that are in disenfranchised and poor neighborhoods. I'll be talking about Columbus in a few minutes. In the Columbus area, you have people living at the outskirts of Columbus and required to go work downtown. They make minimum wage, yet they're driving cars and parking in expensive parking lots because that's the only option that they have. Is that really what we can offer our populations, whether it's in Lebanon or the US or Switzerland, what have you? So there's ideas to think about. So let's talk a little bit more about why smart cities, right? Because a lot of people like to talk about bottom lines. Well, initial studies have shown in the US that if you ship towards electric vehicles, which is another form of sustainable, smarter technology, you're dropping air emissions by 30%. I was told when I got to Lebanon that there was a big issue in Junia about a week ago or so, where people were talking about emission levels in Junia going beyond norms. a lot of it due to transportation. So, a lot of cities in the world are talking about electrification. But in order for you to talk about electrification, you have to have a vision. Do you have the capacity to build charging centers? Do you have the capacity to buy those cars and sell them in the Lebanese market? Connected and autonomous vehicles. I mean, yes, the infrastructure in Lebanon needs improvements and whatnot, but there's a lot of things that you can do through connected and autonomous vehicles that can help you at least manage the problems or improve sections of them so that the population can see the benefit, and then you tie that to a bigger vision. So someone was talking about bus systems. There's a project in Lebanon related to bus rapid transit. How about if you're going to push this bus rapid transit, you want people to use it, but really you're looking for a broad group of the society to use it. Well, some people value their time. If you have that bus connected to the traffic and management center in Lebanon, even if the information is not the best, it's still more accurate than not, where you're giving the user when is the bus leaving, where is the bus now, how long will it take for the bus to get to you. That kind of information, that could influence people's choices in terms of switching and using public transportation. I mean, I'm a partner at my firm, and I use public transportation all the time. I find it much more reliable than driving my car because it will get me to where I need to go reliably. Even if it takes an hour, I know it's going to be an hour, as opposed to leaving downtown Washington to downtown Richmond, thinking it's going to be an hour and a half and getting there in 3 hours. So a lot of things to think about. The other element in terms of also the bottom line, which is the money generated. Smart mobility in particular is a money-making animal in the United States. Just in terms of research dollars that are spent right now, 11 billion since 2010. That's only 8 years. Think about the 5 shared network companies, the Ubers of the world, the Lyfts of the world. They alone generate $129 billion in revenue. Picture this, 2016, $200 million went to traditional taxis in America. $1 billion went to Uber. And the taxis are losing ground, Uber is gaining ground. So it's something to think about. Electric vehicles, we talked about them. Many manufacturers around the world, such as Nissan, who I talked to recently, talked about turning a lot of their models electric. Is Lebanon prepared to handle electric cars? Are we able to deploy the kind of systems that allow for charging? Maybe not everyone will buy an electric car, but maybe we'll have an electric car that is much more affordable. And if it's not affordable, maybe a certain section of the population will start testing and deploying the car, thereby helping us understand what are the real impacts. And then the government can then plan, with the help of the private sector, by the way, because it's not all government here, how to move forward. So I mentioned I was going to talk about the participating cities in the United States for smart cities. So the key point of this slide here is to say smart cities is not a mega region type of project. Yes, you have Washington, D.C., San Diego, Los Angeles in the mix, but you also have places like Idaho, places like rural Nebraska. They are implementing aspects of smart cities. They're very rural, they're very small, they don't have a lot of money. But guess what? It's not about the money. It's about the vision. It's about what you're trying to test. And if your vision and if your ideas are robust and strong enough, you might be able to get investment from the private sector and even investment from the public sector to help push the idea through. And I'll talk a little bit more about that moving forward. So, as I said earlier, I was going to talk about multiple size cities. I'm going to start with large cities. Just so you all know, the cities that I've picked are cities that we've worked with over the past few years. And the cities that I've picked them because some of them address smart city projects, which is a reality, and some of them have chosen a more ambitious approach of tackling a smart city vision for their entire region. So we'll talk about both things here. LA Metro, California. So Southern California is going to be hosting the Olympics in 2028. And, there's no way to put it other than saying they're freaking out about that because LA is already very congested as it is. And in 2028, you're going to bring a whole host of people in. They don't know how they can manage this. So they started to deal with the problem like the onion, peeling it and dividing it and looking at pieces by pieces. They have a big vision of what they want to do in LA in terms of intelligent transportation system, but they decided to start with the freight piece. And here's what interested them on the freight side. They realized that a lot of the freight shipment in the area is moving on their highways virtually empty. Why? Because when you're delivering, picking up a product, and you have this big truck moving from point A to point B, it's relying on the order that it's gotten. You pick this up at 8, you drop it at 10. You do nothing in between. You get to the terminal, Port of LA, Port of Long Beach, you're stuck, you stay there. So imagine how much emission problem that's generating. Imagine how much nonsensical driving is happening on the highways, and not productive. So they've decided to bring a host of stakeholders from the region. They're talking to emergency officers, so police. They're talking to responders, first aid responders and firefighters and what have you. And they're talking to truck drivers, they're talking to passengers, they're talking to technology providers. The idea behind that is they're creating an integrated data platform. What that platform does is you're getting information from different sources. The information goes into the data platform. And I know somebody earlier was talking about privacy and security. These private stakeholders and public stakeholders have decided to provide and share the information. The way the private information is shared into the system is not the way the information is shared outside the system. Meaning, if you're providing them with the time of departure and time of arrival, that's something that they can collect. But they're not providing it. What's your name, by the way? Ayman? Okay, so they're not taking the information and saying Ayman left at 1 and Ayman reached at 2. They will say subject left at 1, arrived at 2. That's all there is to it. So they don't know that it's you. So they have to go through a privacy issue because, in the United States, lawsuits are things that we do very often. So if you decide to pursue someone, for privacy breaking, I should say, that's going to be a big problem. Another big problem with integrated data platform is the cybersecurity attacks. I mean, people were talking about privacy. Think about if you're driving a hazardous truck, a truck that's moving oil or gas or nuclear waste, and somebody tracks that information and decides to just shoot it, all right, because they have the information. That will cause more terrorism or disaster, if you will, for that particular region than any of those planned activities that we've seen in the past few years. So why is LA, to go back to LA, why is LA looking at that platform? Because they're thinking, I integrate the information, everyone has access to it, now I'm making better decisions. Now my driver doesn't have to drive just blindly. He can choose his routes. He or she can choose their routes. They can choose how many packages to pick. So if they have 3 hours, and in those 3 hours they have a lot of idle time, that's an opportunity for additional picking and additional dropping. And the same goes to the end user. If they have access to the information, then if they wanted to drop a package at 8 a.m., but they find out that the truck driver is not going to be able to get there until 11, and they want to add something to the package, just as an anecdote, they can do that. The whole purpose of this application is to create flexibility and a place where you're sharing information that can turn, again, out in the kind of ways that you can use to make decisions, including decisions on emissions. So we're working on this project. I'll be happy to provide you an update on final results, and they come to me. Okay. Midsize cities, and I know timing is of issues. So Columbus, Ohio, probably the most important of all smart cities in the United States. Here's why. A couple years ago, US DOT issued a smart city challenge, and they opened it up to everyone to submit a bid. And they've said that whomever wins this bid will receive $50 million, $40 million from the federal grant, and $10 million from a nonprofit partner, Vulcan, so Paul Allen, who used to be with Microsoft. There were 78 proposals submitted. Columbus won, and we're very proud of that. The way Columbus approached this project, which make it so attractive to USDOT to pursue it, they were thinking of visioning. For them, their whole business of smart city is not about technology, and that's something very key. It's about the people. At the end of the day, transportation agencies, energy agencies, water districts, they're serving people. They're not serving a technology. So let us understand what our people need, and then let's build our entire goals, our entire projects around what the people need, and then let's integrate technology into those projects to achieve them. So Columbus focused on 4 geographies. They looked at the residential district, and Columbus is very segregated that way. You have a very heavy residential district to the northwest. You have a very commercial center to the northeast. Southwest is the downtown area, And then southeast is the logistics or the freight area, where most of their distribution centers and freight logistics happen. So as I was telling you, before, they had vision, they had goals, which are shown in light blue on the top. I'll talk about them in a minute. And they started to think, okay, these are the goals that I want to achieve. How can I ultimately improve safety, enhance mobility, provide economic development, and then address climate change? And if you see, the way they approach it is very flexible, because when you say, I want to take care of safety, it doesn't matter what technology you're using or what system you're using, as long as you're addressing safety, as long as you're addressing mobility. So for Columbus, the projects will likely evolve over time, and they try to build systems along the way, which I'll talk about in a minute, that are easily interchangeable. So if you put a certain technology on the highway, you should be easily able to go in, replace it with something else. So what are the goals? Simply speaking, they want better access for jobs. They wanted a smarter logistics. Columbus is really a hub for freight business. Anyone that drives on Route 70 in Columbus, it's a nightmare. It's basically one car for every 20 trucks. So this is how bad it is. Better connection for residents, so more informed residents, more informed visitors, and sustainable transportation, which is the part that talks about air quality and electrification. So what was the project that they were focusing on when they talked to access to jobs? So they wanted to make access to jobs. You remember when I talked earlier about Columbus having populations on the outskirts and not having access to jobs easily? Well, they wanted to improve their transit system. They felt that people that are not making high salaries, that are living on the outskirts of Columbus, should not be paying a lot of money for gas and for parking. So how about we make our transit system more intelligent? How about we supplement it with collision assistance and avoidance so that, buses are more reliable and safe? How about we upload our intersections and corridors with the right technology so that then you can build an application targeting transit? And by the same token, now people that are willing to use transit now have better information all the time that they can refresh, so that if you plan to leave your home at 8, when can you get to work? If there are delays or problems along the way, what are your alternatives, routes, etc., which is something that's very interesting. The other piece that's really, really interesting, and they targeted the residential district with that, a lot of people complained that, fine, I'll use transit. But my problem is I still need to drive several miles to a transit hub where I'm going to have to find parking. Either way, it's going to cost me $20, $30 a day to sit in that parking lot. Not affordable. So what the city is planning to do is start to build dedicated lanes, self-driving vehicles, connecting transit centers with various areas of the residential district in Easton. So now you can walk, actually, to a center, a mini transit spot, if you will, get on there, go to the center hub, and then take the bus that you need to take to go where you need to go. Smart logistics. Columbus is fascinating. There's a lot of freight, but there's not a lot of information about where freight is being delivered, where it's being picked up, when it's traveling, what is it moving, etc. So the push now is to create a project that focuses on collecting and sharing real-time regional traffic information, both for regular traffic and for trucks. And then part of that collection is to focus on where deliveries are happening, where the pickups are happening, and what are the major truck, between quotation, because there's no real truck routes, but where are the most heavy traffic happening? Based on that, that's going to help them make other decisions in terms of rethinking their freight distribution center. Instead of having one in the southeast, then you're going to have multiple ones in the region. And people can choose to walk and pick up their packages. Or people may choose to, drive short distances to pick up the package. And there's even a conversation about creating autonomous beltways, if you will, that are secured, that can move those packages from those hubs to other mini hubs around specific areas where people can go and pick them up with the right key and what have you. Connected residences. So again, we talked earlier about better mobility solutions. So what they're trying to do is, if we're going to create smartphones that provide you information on freight, and smartphones that are going to provide, and also information on transit, how about connecting that to individual residences and connecting it to things that they care about? So If you are going to be traveling from point A to point B as an individual, instead of you just having to make choices between should I drive, take the bus, take Uber, take the train, what have you, how about we give you a full-on trip? Basically, if you want to go from point A to point B, here's option A, and here's the cost. And you pay one number for the entire option. If you want to take option B, here's your travel time, here's a cost. So they're working on that. And on top of it, what the city is trying to do is implementing that and adding to it other components. So if you're going from point A to point B, let's give you information about what kind of health services provided along the way or at destination, what types of employment services are available at destination, even healthy choices. Someone mentioned earlier that the US has a 30% obesity rate, which is true, but a lot of people are trying to focus on, let's inform people, let's try to get them to think about healthier options by associating that to some of the things that they do regularly, i.e. mobility and transportation. Not just connected residents, connected visitors. So the story here behind it is that Columbus is a major hub for freight, but also is a major hub for cancer research. Ohio State University is one of the best universities in the region. And because of the housing market in the East Coast and how expensive it's gotten, a lot of people have started rethinking where they want to live and looking at places that are competitive housing-wise. Kansas City is one of them. Columbus is one of them. And Columbus is trying to get smarter in terms of what it can offer its visitors in terms of information as when they come. You know, here are your options for travel. You can take transit, here are the services. You can drive, if you drive, here are your parking options, but also here are the parking availabilities. So around the clock, you know if this parking facility has availabilities for your car, what's the cost by time of hour, et cetera, what types of events are happening in the city. College football is big there. And that's something that draws a lot of people and might even attract them to stay in the city. Finally, sustainable transportation. The city wanted to start thinking about how do I deploy electric vehicles? Well, in order to deploy electric vehicles, I need charging stations. I need to convert the city fleets. That's a way to start in order for me to test it. So these are some of the ideas that they were thinking about project-wise. I know I'm spending a little time on this example, but it's important because it really gives you a sense of how the smart city is being implemented, at least in Columbus. So we talked about projects, we talked about various ideas. Okay, how do we get there? So Columbus wanted to do this, this test for these projects and basically started to evaluate various technologies and various tools that it needs to deploy in order to make the projects a reality. These are examples of some of the tools, installation systems that the city purchased and is going to be deploying for it to be able to start pushing those projects, testing them, and collecting information on them, because data is key to determine whether the project is useful or not. More transportation network examples. The other piece, which is really very important, technology for the sake of technology takes you nowhere. Technology needs to be used for the service of a vision. It needs to be used for the service of a particular goal, objective, and then, as a result, project. So what Smart Columbus is doing is they're creating an integrated data exchange platform. They're basically collecting information that they're gathering from their own program, Smart Columbus, but they're also gathering information from non-transportation sources, as well as transportation sources outside of Columbus. To get into those systems, the information is analyzed. It's checked for privacy to the extent possible. It's checked for cybersecurity, which is a major issue right now in the United States. And then the information then is turned into useful data that are used by app developers in Columbus itself to help them build the mobility tools that they're trying to achieve. Public sector for travel decisions and perhaps more choice. Private sector for investment decisions. And then the independent evaluator are tasked to continuously review the work that Smart Columbus is doing and determine which project has failed, which project has succeeded, what type of improvements you need to do, and how do you need to improve yourself as you go along. This is just a quick view of the types of data that I was talking about when I said non-transportation sources, Smart City Columbus sources, and then transportation data. So nothing really earth-shattering, but the interesting thing is a lot of those sectors have not worked together in the past, And now there's a willingness to actually share the information into that open data portal, and then make sure the information is accurate and timely. Because if you need to make a decision, waiting for 6 months to see what happens is not very helpful, particularly if you're a politician and you're not going to commit political suicide by just investing in something that turns out to be a failure. You need to be able to figure out how things are moving quickly and make decisions accordingly. Another piece of the information in terms of how do you make those projects a reality, you need to build also applications. So they're talking about building a multimodal trip planning application. I talked earlier about paying for your mobility in one stop. That's the integrated common payment system. And then there's another piece, which is the inclusive mobility. There's a lot of people in Columbus that don't have the financial advances of others. There are people that are elderly. There are people that are disabled. The application is targeting people with those types of disabilities and developing solutions, travel solutions to address their needs. In terms of electrification, 3 components on that sustainability. Columbus looked at its area and determined that in order for me to become more intelligent from an electric vehicle perspective, I need to modernize my grid, which hasn't happened yet. I need an electric fleet. There's still conversation whether they want to look at some of their public cars and turning them into electric. And then definitely, and most importantly, charging stations. If you don't have charging stations, no one's going to buy an electric car. So that's the example for Columbus, which is really a prime example. Another example, Boston, Massachusetts. So Boston was not interested in developing a full vision for everything in the city. They were interested in a vision related to real-time travel information concept. They want people to be armed with as much on-time and reliable information as possible throughout the day, throughout the year, anytime. So Boston partnered with Waze, and I assume a lot of people in this room know what Waze is, but if not, it's a free traffic monitoring application developed by Google. Waze agreed with the city to share with them all the information that they collect from their drivers with regards to road closures, delays, etc. And then they're turning that information out and pushing it to over 400,000 users. What's the benefit, you say? Well, now I'm going to focus on the last 2. They're able to determine if there are people in Boston that are blocking busy intersections or double parking. I know it sounds shocking, but it's not only in Lebanon that double parking and blocking intersections that happen. And they were able to actually reduce the number of blocking and double parking by a huge amount. Kansas City just started its initiative. Kansas City is doing something even more ambitious than Columbus. Columbus focused primarily on transportation. Kansas, if you look at this graph, they're talking about smart water, they're talking about smart lighting, et cetera, et cetera. And then small cities connected with Marysville, they're very small. They're outside of Columbus City. They have a lot of business along their major route, which is 33, and what they want to become is a test bed. So they don't have problems, but they want technology to come to them because they have retrofitted all their systems with technologies. So if you have an idea they want to test, come to Marysville, test it. What drives smart cities? Customer satisfactions, the need for more responsiveness from the government, better collaboration, reducing emissions. These are some of the things that we found from our case studies that really drove the topic of smart cities. The challenges, not surprising, money. How do I fund it? How do I sustain it? How do I move it forward? Do I have the technology solutions? Do I get support from my leadership, whether at the city level, federal level, state level? Funding business models. Still at the early stage, there is not a clear system yet for how you want to fund smart cities or how you want to develop a business around smart cities. But that's not too shocking. It's still at the onset. I suspect that after the various tryouts, 5 cities from now, you're going to see some ideas of how the business looks like. But from a funding type to date in the United States, the public sector is the one pouring the most money into this because they want cities to start testing those, because the federal government knows they're not going to have money forever. So I'll give them the money now, let them test it, and let them build a relationship with private sector so they can fund it in the future. Business models, 3 types, nothing unexpected. Either the government owns it and runs it, or the government gives it to an entity, contractor, they run it, they manage it until the time when the government says, give it back to me. That's the build, operate, transfer. And then lastly, build, operate, comply, which is the contractor keeps working with it and manages it and tests all sorts of technologies. The government is just checking for compliance. So I'm going to wrap up very quickly, just 1 minute. On the way on the plane coming to Beirut, I was thinking, Wissam asked me to talk about the American experience, and I did talk about that, but I grew up in Lebanon, so it's not like this is an environment that's not familiar to me. And I remember growing up and people saying, well, but this is the United States, a different ballgame. They operate differently. That's not applicable to us. So I started to think about, my repertoire of projects and what have I done recently and what examples I have in, well, Kenya. Nairobi is the most intelligent city in Africa. Konza City is 60 kilometers from Nairobi. It is dubbed the Africa Silicon Valley. Nairobi and Konza City are following Singapore's footsteps in terms of smart city. They are using data for connected transportation, for connected water, for connected energy. They want to reduce accidents, they want to have better consumption, and they want to have better transportation. I don't think Lebanon is not prepared for smart cities. And I've heard the contributions before. Yes, the system is weak, but the geographic landscape lends itself for a lot of potential. You can develop a vision, and I know there's conversation about doing a transportation national plan for Lebanon. There's conversation about a bus rapid transit system. So you have an opportunity here to equip your plan with ideas about how you'd go about improve your system. The system is weak, it's not painted. All right, let's paint the system. Energy consumption is poor, water consumption is poor. Let's understand first if there are leakages. Let's think about those technologies that we can use to improve our energy system, to improve our water system. On the transportation side, let's test things. I know a lot of parts of the country have talked about testing ideas. You have the opportunity in Lebanon to take advantage of the donor state revenues to fund these types of projects or operational improvements. You also have something that no one has, which is local talent. I mean, I'm not saying this as a Lebanese or someone that lived in America for 20 years, but the Lebanese are very creative. Someone mentioned to me earlier, we don't have metro, but we invented the service, which I thought was funny, but there is some reality to adaptation. So how can we use technology, our talent, our geography, our demographics, and the potential investments and revenues that can come in to improve Lebanon and make a case for a revival. And thank you.
Thank you very much, Marwan, for a very informative presentation, which I guess will generate a lot of questions during the question and answer session. I'm pleased to present Dr. Sarah Najm. Sarah received her BS and MS in physics from the American University of Beirut with focus on network complexity and dynamics, and her PhD in physics from McGill University studying out of equilibrium system. Please note the choice of the topic fits perfectly the Lebanese case, out of equilibrium. Sarah's work was recognized by the Natural Sciences and Engineering Research Council of Canada. She was a postdoc fellow at Princeton and at California Institute of Technology. Currently, she holds a position at the National Center for Remote Sensing of the Lebanese NRS. Dr. Najm's presentation will cover machine learning and urban physics for resource management in Beirut. I will not venture to tell you myself what Dr. Najm will be informing us about, but from the little I know about her work, I warn you to be careful if you happen to be engaging in any fraudulent electricity consumption. As this smart scientist will catch you through her remote sensing machine learning techniques. Dr. Najm, the floor is yours.
Thanks a lot. Thanks for the presentation. And it's true, I'm going to be speaking about the energy. So I'm going to be walking you through machine learning and urban physics, not in the States, not elsewhere. It's in Lebanon. It's in Beirut. Apply to probably the biggest problem that we're facing that we need to deal with at the daily level, the energy, with all its sort of sections at the production level, the consumption level, and the technical, non-technical losses, which are probably what we're going to be reaching at the end of this talk. So I'm going to be walking you through this workflow that we developed at the center. It's an in-house, almost near automatic workflow. So we started with a survey data by the USG team led by Jocelyne Gerard. She handed us over data with around 7,000 buildings which are surveyed. Each building is tagged with the year of construction, number of floor, number of apartments, and function, so that we have a building use. So we use that data on two different paths. One is neural network, for us to be able to tag every building in the city with a year of construction and a use. And the other track is to basically develop an automatic detection tool that will be able to assign feature to the newly detected buildings and give us a lead into the energy consumption patterns, the production, and also fraud detection. So the survey data, together with satellite images, which are the Pleiad, so these are triplet images taken from 3 different angles, allowed us to recover heights and the EDL, which is the Électricité du Liban consumption at the building level in Beirut. So we have electricity consumption at the building level, we have the building heights, and we have the data that I described from the USG. So this is basically the USG data set. So these are basically Ras Beirut, a big bunch of it, and Ashrafieh, and part of Basta. So these, as you can see here in our database, you have the year of construction of each building, the number of floor, the number of, so see there are some outliers, some wrong entries, and you have the function, which ranges from residential to offices, mixed usages. So we use this data set with a Pleiad, which basically takes an image of Beirut from 3 different angles to recover the heights of the buildings. And then we went to the EDL data and matched each building with its electricity consumption. So our data set now is a data set what we call a training set. It has the year of construction of the building on the one hand, together with its use, so the building function. So these are known for the survey data for the only 7,000 building, but we don't know it for the rest of the city. But for the rest of the city, we know the height, the energy consumption, the area, the parameter. So all these things are known. So the question was, can we use this information to tag each building of the city with the year of construction? And along that, give each building its features, so we know the material of construction, the window-to-wall ratio, the floor ceiling, the floor height, the thickness of the walls, and all these things. And knowing that, the year of construction on all these things, can we infer the building use? So the answer is yes. We just have to feed all these into a neural network and recover the relation, which cannot be sort of a closed-form solution. So you cannot write down equations. It's a neural network, so you feed it information and it spits out information. So what we now feed this in is data about building height, building consumption, energy consumption, area, and parameter, and it would tell me the year of construction of the building. Same thing. Now I know the year of construction, I know the building height, the area, the parameter. I can now tag the building with a use, because I also have the patterns that I inferred from the data from the USG data. So this work is done in collaboration with Dr. Aram Yeretzian from AUB, from architecture at AUB. And once we tag these buildings, as I said, with this year of construction, we used George Arbid's work, and we sort of gave an archetype for each building. So this building, for example, is from the 20s. We know that the floor height is this, the wall thickness is that. That's the typical number of floors. That's the typical area of the flat. So now that we have that, we can do it for the whole city. So these are typically, for example, archetypes that we did for the era from 1900 to 1923. So these we just like sieved from the thesis, and then you can see here there's the material characteristic. We know the kind of stone construction, that we know that this is stone construction, the partitioning, the ceiling, and the ground floor. So all these things are now known. So what would this give us? In addition to the other end of the project, now that we have the building footprints, we can overlay them on the satellite images and get the corresponding image for the building footprint, which gives us something like this. So we have thousands of these images, which constitutes also another data set for deep learning. So now we have a typical building in Beirut would look like this, for example. Okay, so we have many of those. So we give these to the deep learning algorithm, which is a convolutional neural network, for those of you who know this terminology. And the algorithms just goes over the satellite image, it tries to tag whatever it finds. So we get something like this. So from what it knows as a database, it tries to learn to discover new buildings. So we can actually detect newly built buildings, get their heights, get their area and parameter, and then give them a year of construction depending on the year they were detected in the satellite image. So now that we did that teaching, or for the from this subset of the data to the whole city, we can recover the 3D model of the city, the full city, with all the details of the window-to-wall ratio, the heights of the floors, the material construction, and what have you. So this is pretty much like part of sci-fi. So you can see all the buildings are tagged with their functions. So you have this residential building from this period of Arbid's work. Then it has this given material. And so this is done for all the buildings in the city. And this is part of my PhD student who's in the audience, Ala Akrayim. This allowed us to do this. So this is Beirut, fully 3D extruded with all the details from year of construction, material of each building. But these are predicted, I just have to warn you. So we need to do a lot of ground checking. And from that 3D model, I said that we know the building use and whatnot, but we can also confirm the building use using traffic data. So this is supposed to be a movie, but it's not moving. So we had traffic data, which we got from this app called Tariq. It's basically following users. It has like 40,000 users, and it's been in the App Store and in the Google Play Store for over 6 years now. And it's gathered like a huge amount of data on the patterns of mobility towards Beirut from the north, from the east, from the south, and inside Beirut. So when you follow a car, for example, at 7:30 a.m. in the morning, you know that this user has started at this point. So his starting point is more or less a residential area. And then the person moves in the city and like parks at around 8. Then you know the region where the person had parked is more likely to be offices or a place of work. So this, we're also trying to complement our data on building use with this traffic data. So this is helping us tag building use using traffic. And so now that we had the full 3D model of the city, we can remodel solar energy production, which is the renewable part. So we have the total heights of the buildings, and we know their areas and whatnot. So we can model the overshadowing effects on the building rooftops from nearby buildings, and we got this map, and it's online. I hope you bear with us with the low quality of infrastructure that speakers have been highlighting. So the website might be slow at points, so you just have to be patient to get to the stage where the map loads, but we're moving to another server hopefully soon. So this map allows you to query each building in the city, to query the energy, the total irradiation on the rooftop, and given the electricity consumption which we got from EDL, we can get the efficiency of the solar panels on that particular building. So if this building is, for example, inhabited by one family and it is capable to produce energy for 4 families, for example, you can just pass on the energy for neighboring buildings. So this is the first step towards this energy management platform. So this is basically energy production. Energy consumption now is, since we have this building archetypes or the building features, we know the number of floors, the material used, the window-to-wall ratio. We ran a full model on both sides of Beirut, so Ras Beirut and the Ashrafiyya area, and we got the spatio-temporal distribution of energy. So now, we're in the process of generating the animation. So if you have a time slider, you can actually know the energy consumption at the building level, at the hourly level in Beirut. So now we have it, if you go to query it from EDL, you have it at the bi-monthly level. So that's how the JB goes and gets the data. So every 2 months you go, they check the meters and they update it. But now we can actually sort of predict how much energy each building is consuming given the archetype of the building. And this basically gives us a better, if there to be rationing schedules, they have to be properly and smartly managed. So you cannot turn off the power on the offices during working hours, okay? And you cannot do it for residential when people are back into their houses. So this gives you a cue on if you need to cut down on energy, it's how you should manage it. And even you might not need to get into this rationing schedule if you properly know how to manage your production distribution. Finally, so given the building characteristics, so we know a typical building from the 20s, for example, has an electricity consumption of X, and a building from the 90s with that number of floors has an electricity consumption of Y and whatnot. So if we now feed in the energy consumption, the actual energy consumption, to an autoencoder which is capable of detecting outliers. So I tell it, this is energy consumption, tell me which one is potentially fraudulent, okay, given the building characteristics. And we did that. So I'm gonna code it and say it's potentially fraudulent energy consumption because it's righteously so. It's potentially fraudulent because there are buildings, I'm gonna just point to one. So this is a building from the 90s in the Antari area. It has 0.3% consumption than the typical consumption. So it's like really pretty much not using any power. So we thought, okay, they might be playing with the meters or not, but then we had sent someone to check it, and the building was not inhabited. So it's potentially fraudulent, but it's not. And the consumption was done by the Natur, so that's the only consumption of the building. So there are other buildings where you can see it, but this map is non-interactive, but if I was to connect my computer, I would have shown you. So there's a building here, for example, from the 20s, and the electricity consumption was 180 times more than typical consumption. So we went and checked it. It was really not the case. So the building was demolished and a new building was erected, and that was not updated in our database. So, it's this whole dynamic process of updating our city using this workflow. So, this is pretty much what we did. We didn't do the resource management because we have production, we have consumption, we have potential fraud. But this now feeds into a resource management system, but that's pretty much what we can do at the moment. So we'll leave it for managers to do it, and I'll wrap up and finish at this Thank you.
Thank you, Dr. Najam. We will have a question and answer session. I'll allow myself to pose a question to each one of the presenters, then we open it for the floor. I beg you, because of time, if you have any comments, let's not have comments, let's have questions so that we benefit from the presence of the presenters. What I will pose to Marwan and to Dr. Sarah is not really a question. And I leave it for them to if they want to answer it or to guide them in answering some of the questions.
It's not political.
Huh?
It's not a political question.
No, never. Well, we commented in the first session, and everybody knows that our cities in Lebanon, as they are now, they lack a lot of what is needed to get to the level of a smart city. So this begs the important question of should we be leapfrogging? Let me explain for the people who doesn't know this term. Leapfrogging means advancing from the situation we are now in without progressing through all or any of the stages in between. يعني إذا بدي ترجمها للعربي بدنا سياسة حرق المراحل. نحن بوضع تعيس. We want to be in a better situation. We don't want to move in the classical way how things are usually progressing from a totally يعني, developed systems and networks to the smart city by following the same steps that other cities in the world have went through. This is at the concept of smart cities, but it also applies in orienting our thinking in so many ways. I want to give a real example that we are living through. All the citizens of Beirut, if not all, most of them, complain from the lack of enough parking. They think that we don't have enough parking in the city. So the immediate reaction would be we should build parking. And the municipality has very expensive, several parking, multi-story parking projects. Nothing have started yet, but it seems it could be coming. While everywhere else in the world, the thinking is different. The thinking is to reduce the parking and instead develop your public transport system and your soft mobility in such a way that to make parking less needed. This encourage people to need for parking. So instead for us to go from a situation of lack of parking, we have to jump directly, leapfrog this situation, not by going through building parking spaces, but going into smart transportation. And this is what I would like to check with Marwan on. Does he really agree with me that in order to go to a smart city situation, from our current situation, we have to leapfrog?
I guess my answer would be it depends on the project. So the answer is yes and no. Taking the example of parking, because you asked that question, is the problem related to citizens of Beirut lacking parking, or is it visitors to Beirut lacking parking? So, I mean, in terms of solutions, again, I'll go back to the examples that I'm seeing. I live in Washington, D.C., and I own my place in downtown D.C., and I have parking. And I was looking, a neighbor of mine wanted to sell his house. So he did sell his house, but he sold his house in two pieces. He sold the parking for $200,000, one car, and then he sold his house. So my point is, parking is very expensive in a lot of urban cities. And what Washington, D.C. has opted to do instead of, because no one can afford to buy a house anymore if your parking costs $200,000, right? So how about we sell houses, but how about we find different solutions for parking? And so what they've been trying to do, to answer your question, is there needs to be some sort of, that's what they're working on, dedicated lane or non-dedicated lane transportation that's connected or autonomous that can take you from the outskirts of the city to multiple locations. And then from there on, you may choose to say, I'm going to Uber for half a mile, or I'm going to walk for half a mile, etc. But there needs to be a push, I guess. Solving it by building more parking is actually creating more problems. You solve it by basically saying, there is no parking, you're coming from suburban area, here are your options. And they are transit related. And the transit system would be equipped with better information systems so that the people, when they pick it up, it's cleaner, it's timelier, it's reliable. Forget about timely, it's reliable. I know when it's coming to me and I know what I'm getting there. That would be one example. But can I just add one thing in terms of leapfrogging? What I was thinking about, I was meeting with a couple of people with CDR. Is that okay? So basically, and I was talking to them, they were complaining about law enforcement and enforcement of various types of traffic violations, like people driving on the right side of the highway, or parking, double parking, or again, Boston again, double parking, or parking on a busy intersection, etc. So if you think about connected data, if law enforcement doesn't really have the time or the focus or what have you to be tracking those projects, how about you bring those tracks to them? And this is one thing that you can take advantage of, connected data, basically. If you can put sensors on your lights or where have you, again, getting creative in Lebanon. I don't know the market as well, so I'm only building from what I've seen, what I heard, and what I know from the States. Building those connections so that maybe the light can detect if a guy is driving or a girl is driving, typing on the phone, talking on the phone, parking in a legal parking spot where the parking spot can read that it's illegal, pick up your plates, send you a ticket, and see what happens as a result of that. A lot of problems in Lebanon are not all just because of the network being weak. I mean, I drove to many locations since I got here. I come visit my family all the time. And sometimes you're driving to downtown Beirut and you're like, why the heck did I spend an hour and a half on this road? And then you realize that, well, the guy that's 6 cars behind you just circumvented everything and wants to get in. And the next guy, and the next guy, and the next guy. And you're sitting there like a complete schmuck. You're like, okay, I'm the only one doing the right thing, but everyone is here. That's not a problem that a highway will solve. That's not a problem that, energy will solve. Yes, there are other problems, but my point is, I like to use the example of cancer, right? If you have cancer, God forbid, and you're trying to deal with it, first step is to manage it, then to eradicate it. So your leapfrogging is sort of a first step of management. Then when you start managing, you stop stopping the bleeding, if you will. Then you start thinking about even smarter solutions. I mean, smart cities are about smart people, and smart people make decisions regardless of the situation. I work in strategy consulting. I put in front of projects that are sometimes unsolvable. And, you think Lebanon has problems, India has problems, Myanmar has problems, even the States. I mean, it takes a century to get things going in the States because you're dealing with multiple stakeholders and different interests. And every 2 years, speaking of politics, the tide changes. One day it's left, one day it's right. So projects get put on the back burner all the time. There are solutions. It's just that, you have to at least propose something. To me, when someone was asking me when I was in Paris, talking about the same topic, and they said, well, we don't know what we want to do. And I said, well, the only thing that you can do is test something. You have a vision. You have goals. You say you have a vision, you say you have goals, but no one's achieving them. How about we pick a location in Lebanon where it could be done? I give the example of Marysville, right? They don't have problems, so they want to be a test bed. Surely there are spots in Lebanon that are less congested, less problematic, where you can actually deploy and test something on a small scale, show the results, and then market it. Get the private sector to support you. There's a lot of options. I'm optimistic because I'm of the philosophy if there's no other options. I mean, what's your other option? Pessimistic? then what do you do? Wait for that? I mean, you have to do something, or at least try.
Thank you very much, Marwan. We listened to Dr. Najm, and I guess many of us probably have thought, well, what does this have to do with us? This is too theoretical, this is research. I want to make a comment and probably ask Dr. Najm to support what I'm saying. I think it's very important to understand that the role of research is very big role for research in promoting evidence-based policies. We have a problem in this country. We don't have policies for almost everything related to the interests of the people. And we want those policies to be based on evidence. Evidence-based policies come from research. So what she is doing, and a lot of researchers are doing, are very much practical. This is not theoretical. This is how we can guide our big decisions, decision making. If you like to comment on that.
Yeah, I mean, this is probably the first time I speak about this full workflow on the production, consumption, and fraud system. But we've had another successful story of evidence-based research, which is the nation-scale solar energy. So we were looking at the potential areas for solar farms in Lebanon. So we looked at the regions where the solar energy would be suited. So we filtered out hazard zones, highly rugged topographies and whatnot. And we produced this map. And we put up this map in a policy paper at the Assam Paris Institute, and it snowballed. So people started talking to us about it. And I don't know if you've heard the Prime Minister, I don't know, like a month ago, he had pushed the share for renewables in the energy mix in Lebanon to 30%. So that 30% didn't come from thin air. It was really based on our work that we actually surveyed land in the Beqa and Baalak and Hermel, and we figured out that there's 100 kilometers squared of highly relevant areas for solar. And we calculated the potential, and and these were in public lands, so the government wouldn't have to pay a penny to all the land. So this number was basically just driven by, but the most important thing is, like, I walked you through this kind of technical piece of academic work, but I think a very important part of it is communication. Like, we have to really communicate our findings and our research in ways that, like, the average person who picks up the newspaper and reads an article about it would know that this is what these people are doing and this is how it's relevant for us. So communication is the next step, and we're not there with this project yet. But we've done it with the renewable energy, so for sure.
Thank you very much. What we are doing here is communication, those kind of events. Now we have some time, as long as you wish, for questions and answers.
There's a question over here and a question over here.
Okay, شوف مين.
Hello. This is really interesting research that you've done, Dr. Sarah. I have a quick question. Other than the radiation potential solar energy that can be produced from the roofs, I think it could be really interesting to see the consumption of energy versus the design of the building. And you can come out with very interesting design guidelines for the buildings in Beirut. This is from one point. Second point is, you're doing a lot of work in order to understand the design patterns and the actual design of the building. And I think here we're sitting at the order of engineers that have the records of all the buildings that are being constructed, but they're in papers. Has this conversation been carried out with the order of engineers to see if there's potentially a way to digitize this record keeping, or even to require 3D modeling or BIM as at the moment is the trend in the industry to have actual meaningful models submitted that can be directly converted into information of building height and floor-to-wall ratio and occupancy and everything else. Thank you.
Yeah, so I'll answer the second question. When I first attempted or started this kind of work, I was like an individual with no portfolio for me to prove anything, and I can do anything, okay? So I was not really taken seriously, but I mean, I work at the center, or National Center for Scientific Research, the Remote Sensing Center, so we had a wealth of data. So instead of like just knocking on doors and like trying to digitize data that is in hard copy form, so we try to circumvent it using our kind of machine learning and AI machinery. So it was a way to circumvent a sort of a slow process of digitization, to say the least. Yeah, but we have to pay for them, at least from the municipality. So you pay, and we have no resources at the time we started. But this is growing now, and it's reaching its end stage. So there's you have to buy every lot has a price for you to acquire data. So who? Yeah, but we don't have them. We don't have access to them. Yeah, that's good. So that's one thing. So when it comes to these energy consumption patterns, this is our ultimate goal. So like figure out the buildings that are really like energy greedy and like recommend retrofitting sort of regulations. So we're in the process. We're not there yet, but this is basically the goal of it. Thanks. Yeah, there's a question over there.
Hello, Dr. Sarah. Just one simple question. Similar to your problem with the order of engineers, is your data open for other utilization, other aspects, other studies, which I see a very big potential from the base data that you have? Is it an open source or is it like the order of engineers?
Absolutely, but we're just doing this fine-tuning over the data. So once we're ready to get it out, we will put it out.
How can we?
So it's, I don't know if my contact is probably somewhere in the, I don't know.
Okay.
So I mean, I work at the National Center for Scientific Research in Mansouriye so it's the National Center for Remote Sensing.
Okay.
So if you go there, you can acquire data.
Have you considered laser scanning for validating part of the model, which you said you'll do?
The validation for what? For
the neural network model that you have built for the city.
So the way we did the validation is splitting the data actually into training and validation sets. So that's how we validated. So the prediction on the test set was doing very well, so around 98%.
Okay.
So that's how we did it. But definitely ground data is required. With little resources, we don't have it.
This is what I'm saying.
Yeah.
With the laser scanning, probably it will validate the whole thing in
We haven't.
very short time.
We haven't.
We have. Okay. Thank you.
We have the time for 2 more questions.
Marwan, you were talking about Nairobi, which has some similar problems as Beirut has, from power point of view, from water, from waste, and such things. My question is, who initiated your work in Nairobi? Was it the municipality? Was it the government? Was it a ministry? And how did things, if you can just explain the administrative,
So in the case of Nairobi, a lot of it came from outside funding. So that's why I mentioned in my presentation donor states. So it had some money coming from the United States. I don't remember if it was USAID or something like that, but there was some funding coming from the outside. And the government of Nairobi worked hard to try to get tech companies to become more interested in Africa. There's a lot of competition actually right now for African countries, especially countries outside of Southern Africa and Namibia. It's basically a competition of who can have more influence. America is interested, Japan is interested, China is interested. So in that kind of environment, there's a lot of interest in spending the money. Just come to me with the right idea and show me some commitment that you want to bring in technology to your country. So.
one quick question to Dr. Sarah. Do you think that if we adopt this model on all the buildings in Lebanon, that maybe the current production of electricity of maybe 1,800 megawatt will be enough? I mean, if we really optimize our use of energy, of power, and we cut the sources of leakages and all of that, maybe what we already produce might be enough for us. So can you go and maybe prove something like that?
Yeah, I would say one thing, but I wouldn't venture and say we the management will do it. But so when we're modeling the energy consumption at the hourly level, we actually model a continuous consumption. But what the data of EDL has is this suppressed usage. So when the user is has no longer electricity, she or he shifts to the local generators, and the way people use the power from the generator is behaviorally different from the way you use it with normal electricity. So what we have is basically we're missing on the suppressed demand when we look at the EDL data. So what this model would be able to lead into is this gap between the EDL data and the suppressed demand. So it would tell me really what would be the typical consumption of the city if it's a big if, the electricity production was continuous. So then we would compare it to actual productions and see whether there's a real gap with production and consumption. So I wouldn't say management would solve it, but we would need these numbers to figure it out. Yeah, it's true, but people do, when they use for example, the behavior change, so it's not really typical. So even if you look at the amounts of fuel by these local generators, it wouldn't tell you what would the actual demand be if the electricity production was uninterrupted.
Thank you. I would like to address my question to Dr. Najm. Are you willing, or did you already communicate your findings with the Minister of Energy? I think I'm complementing the question of... are you willing to do it? If not, because you are already a national council, so you should go.
We're in very close collaboration with the EDL itself. So Mr. Kamal Hayek has been very collaborative on all this effort. So he provided us with the data and whatnot. So now we've reached a stage where we can say, okay, we probably have a system that you could benefit from. We need proper data because the data is pretty much based on prediction data. So feed it in the proper data, and you probably would manage the resources in the city properly. Right? Because if you look at the schedules or what they call it sectors in Beirut, so the Beirut itself is divided into sectors in EDL, and they have for each sector a ration schedule. So there's an outage schedule for each. And schedules are not really smartly done, Once you really match the schedules with the actual functions of the buildings in that area, then you would say, okay, I'm properly now matching production to consumption. So this is only when it happens. Thank you.
I want to thank very much Mr. Marwan Madi and Dr. Sarah Najm. Maybe we don't have any more time for that. I can't keep you longer than that. We were 15 minutes off schedule, and I think now we are 20 minutes off. So I want to thank the presenters, and I want to mention it that tomorrow we have a very rich schedule. There are talks about experiences in Barcelona and in Estonia, and there is a very rich panel discussion that have a lot of people who each will talk very little but open to a lot of discussion. Join me in really thanking the presenters, and see you tomorrow. شكرا كثير مروان.
Oh, thank you. I'm glad that you